All right, y'all. So 9.7 deals with applications using growth and decay. Okay, so growth and decay, we're looking at exponential growth and exponential decay. So growth we can look at such as population growth, investments growing, and so on. Decay, you could look at stuff like radioactive decay. And when something decreases over time, we call it a decay, okay? So I'm gonna give us the formula to start out with. So y'all, it is P parentheses T. So in the formula, P basically stands for the population at any time T. So remember, little t is our variable, okay, for time. All right, that's going to equal, well, let me let one in real quick. That's going to equal P sub 0. So that's just symbolism, okay? It's like a subscript. E to the KT. All right, so the PO, that would be our initial population or amount. So if I was using the formula for an investment, that would be my actual investment amount, okay? E, we know that's Euler's number. The K is our growth rate or decay rate, or it could be the interest rate. So depending on what we're using the formula for, could be any one of those, okay? And then we know what T is. T is our time in years. All right, so this is the main formula. Now, based on this formula, we got two more we're going to look at. So the first of the other two will be a capital T equals the ln of 2 divided by RK. When you see a capital T, this formula, that means double time. So this formula finds the time it takes for the population to double or our investment to double, okay? And then we got ln2 over K. Remember, K is our growth rate still. But it could be interest rate or any of the three, okay? So this one finds the double time, the time it takes for your money to double. And we can also solve it for the K. So that K equals the ln of 2 over the double time. So this formula, if you know the double time, it figures out what the growth rate needs to be. Okay, so there'll be one problem where they ask us for this kind of info, okay? Most of them are going to be based on this here equation. Okay, so like I said, this formula, we could estimate populations in the future, estimate how much money is in an account when we invest over so many years, and so on, okay? Now, we'll say this, when we use this for investments, you remember before we had compounding that was like quarterly, semi-annual, monthly, and vice versa. For us to use this formula with an investment, it has to be what we call continuous compounding. All right, y'all, so let's see this first example. It says in 2012, the population of a city was 5.86 million. All right, then it says the exponential growth rate was 2.12% per year. So they're going to give you that kind of info. And then on part A, so this one has, looks like A, B, and C. So for part A, they want me to find the exponential growth function Okay, so part A, we just want to find the exponential growth function. So basically, we want to find what formula we're going to use for this problem. So they're going to give you the P of T. What we got to do is fill out the formula, okay? So notice it starts with our initial population. They told us that was 5.86 million. So we're going to bring down our 5.86. Now, I'm not going to write million. Just remember, whatever we get out of this will be in millions, okay? All right, next we got to put E. Next, for the exponent, we got K times T. So what we got to figure out is our K. Well, y'all, K is 2.12%. But we got to convert it out of percent and put it into decimal form. So if you remember when we did, I think, section 9.3 with the investments, to turn a percent into a decimal, we have to move left twice. So that means I'm going to have to add me a 0 for this one, and I get a 0.0212. Or you can take 2.12 and divide by 100, and it'll give you this. So basically, when you move that decimal left twice, you're dividing by 100 on these, okay? All right, so I got my K, so I would put in 0.0212 times T. So now, knowing how many years passed, I could use this formula to estimate the population in millions of that city. So y'all, this is what Math Lab will want right here. Now, part B, they say the population of the city in 2018 is what? Well, so they want me to find the population of the same city in 2018. So what we got to figure out in order to use our formula is what is our T? How many years passed from 2012 to 2018? So all you got to do is subtract those. 2018 minus 2012 gives us a time of 6 years. So we're finding P of 6, because that's the number I'm going to put in for my variable, okay? So I would have 5.86 e to the 0.0212 times 6. Now, y'all, they want me to round 1 decimal place. I'm going to share my calculator and punch that in. So we had 5.86. Then I'm going to use the second ln to get the e with the exponent. And that'll be 0.0212 times my t, which was 6 years. All right, y'all, so remember, we're rounding this 1 decimal place. So we're going to hit enter. All right, so that'll be the 6.6, but my 6 has a 5 after it. So I'm going to round that 6 up to a 7, and I get 6.7. So y'all, for this one, we would put 6.7, and then MathLab already has the million. So all you're putting in is the 6.7, okay?
Can you show the steps on the calculator one more time?
Okay, so yeah, I just punch them in just like they look. So let me find it. So first I'm putting in that 5.86. Now, since I want the e with the exponent, I'm going to hit the blue second button and then come down here and push the ln button to get that e with the little x by it. So that little x is for my exponent, and I put in my 0.0212. And then I just use parentheses for my multiplying and put in my 6. But y'all, if you wanted to, at that point, you could put 0.0212 times 6 as long as it's up there in that exponent, okay? All right, then I hit enter, and I was rounding it 1 decimal place to get me a 6.7. All right, now C is a little trickier because this one says the population of the city will be 8 million in about blank years after 2012. So if you notice here, we're looking for time on this because we're looking for some kind of years. But notice what they gave me. They want to know when will it be 8 million. So that's going to be like our P of T. That's like the ending amount we're getting. So the 8 million will go for our P of T. So we're going to have 8 equals 5.86 e to the 0.0212 times t. Because y'all realize, since we're looking for years, t is what we're actually going to solve this for, okay? Now, the trick is solving this until we get our t. So y'all, our first move, we need to get this e by itself over here with the exponent. So if I want the e over here by itself, this 5.86, since it's being multiplied by the e, we're going to divide both sides by 5.8. Well, 5.86, okay? So divide both sides by that. So what happens? The right side cancels out. Now, I'm not going to divide this yet. Okay? So I'm going to have my 8 over 5.86 is going to equal my E to the 0.0212 times T. All righty, so now we want to bring this exponent down and put it down here with that E. Now, to make an exponent come down, we got to take a log or an ln of both sides. So since we got an E here, we're going to take the ln of both sides. The ln of 8 divided by 5.86 will equal the ln of E to the 0.0212 T. All right, y'all, at this moment, I can't do nothing on the left side, so let me bring that up. So I'm going to keep that a ln of 8 divided by 5.86. But y'all, this side, remember, a ln is really a base E log. So this is like a log E of E to the 0.0212 T. Well, remember, when the base matches the base raised to an exponent, the answer is the exponent. So if you take a ln of an E, the right side is going to be nothing but your exponent. But now it's brought down where I can actually solve it. So to solve that for the T, I'm going to divide both sides by the 0.0212. So I'm going to have a ln 8 divided by 5.86 divided by 0.0212. That's going to equal to 0.0212 T divided by the 0.0212. Y'all look at that. The right side, that cancels. All that's going to be left is our T when we get done. And we're going to round this in 1 decimal place also. So I'm going to put this in looking like a fraction. So watch what I do on the calculator. All right, so let me clear everything off. So I'll make it look like a fraction by hitting alpha, y equals, and enter. Now on the top, I had that big ln. So I'm going to hit my ln button. And it looked like a fraction, so I'm going to do the alpha y equals again and enter to make my top look like a fraction. I had an 8 on top, arrow down, 5.86. All right, I'm going to arrow out and close in parentheses they got open. And then I'm going to arrow down to the bottom, and that was just a 0.0212. And then if I arrow out, it looks exactly like what's on my paper. So you want to use the green alpha button and y equals to get them fractions how you need them, okay? All right, remember we're rounding 1 decimal place, so I'm going to hit enter. So y'all, let's see, that'd be 14.6, but the 6 has an 8 after it, so I'm going to make that a 14.7. So that means in almost 15 years, the population will go from 5.86 million to our 8 million. All right, y'all, I think I can get part D right here. They want to know the doubling time. So they'll say the doubling time is blank. So I know the formula I gave y'all up here. T equals ln of 2 over k. So T will equal ln of 2 divided by our k. And our k was 0.0212. Now, look here. 5.86 million is started with. It took almost 15 years to get to 8 million. Well, y'all, if we double this, that's going to be 10, almost 11 million, which is more than 8 million. So the doubling time has to be bigger than that 15 we got here, okay? All right, y'all, so let's punch that in, and we're going to round that 1 decimal place. So back to the calculator. So this one ain't bad. I'm just going to do a ln of 2, close parentheses, divided by 0.0212. All right, y'all, we're going to hit enter. So it's definitely longer than the 15 years. It's almost, what's that, 32.6, but I got a 9 behind it. So that'll be, what, a 32.7. All right, so in almost 33 years, that population will double for that city, okay? All right, y'all, so let's see my next example. We're going to fill out a little table they gave us. All righty. All right, y'all, this one says complete the following table. It's got 3 columns here. The first column is population. These are like our headers. This one has growth rate, which is our K. And then the last one has our double time, which is our capital T. Now, they got country A and country B. So these will be our rows here, okay? Now, they gave me the growth rate. The growth rate of country A was 1.2% per year. But they didn't give me country B's growth rate, so I got to find that in a little bit. Now, they didn't give me country A's doubling time, so that'll be what we find for it, and this will be in years. But they did give me country B's double time, and it was 27 years. So let's find the double time for country A. So double time for country A. So that little subscript A means this is the double time for my country A, okay? So remember, it's ln of 2 divided by K. Well, the K is 1.2%. But I need y'all to turn that into decimal form for me. So I'll have y'all do some of these for this one, okay? So I just need y'all to tell me what 1.2% is in decimal form. All right, y'all, so let me see y'all. So y'all go with, yeah, 0.012. Remember, you got to move it left twice. So you move it from in front of the 1, and then you would have to add a 0 to move it in front of that, okay? All right, so down here we would put 0.012. And y'all, it looks like the double time they're rounding off to the nearest year on that, okay? So y'all punch that in and tell me what y'all get for the years for country A. And so remember, when y'all rounding it to the nearest year, you will not have any decimal places, okay? Oh, that is close, but what's after your decimal? There you go, 58. Good job. So y'all up here, all you would do is put in your 58 on that part of the table. Then for country B, we got to find the growth rate, K. So we're going to find the K for B, which will equal ln of 2 over its double time, which is 27 years. All right, y'all punch that one in and tell me what you get. And that one I'll take whatever amount of decimals y'all want. Okay, so I'm going to put that in point. So 0.026. Now, let me ask you this. This is decimal form, but look what they want. They want it in percent form. And it looks like they're going one decimal place, so that's going to be good. So remember, to turn a decimal back into a percent, instead of moving that decimal left, we're going to move it right 2 places. So if I move this right 2 places, that's going to give us 2.6, and then we can add our percent. Now, Nancy rounded just one decimal place though, okay? Now y'all, they already got the little percent part out here, so don't put in the percent, just put in the 2.6 on that, okay? All right, y'all, looks like our little table's filled out, so we get to move on. So next we got an investment problem. But this investment problem will have continuous compounding. So we're going to use our new formula, okay? So y'all watch this. Suppose 14,957 is invested at 6.4%, compounded continuously. Well, this will be like number 1. It's got a part A. Find the exponential function that describes the amount in the account after T years. Okay, so that describes the amount in the account after T years. So basically, like on question 1, they're going to give us the P of T. We just have to fill everything out. So what I need first is, what would we put in for our P initial? What's my starting amount? And y'all, that's what 14,957. Then remember we got our E. And then we got our K times T. So what is K? K is 6.4%. I need that in decimal form. All right, 0.064. All right, so that'll be 0.064 and then times our T. So for part A, they just want you to put in the formula that we're going to use. Now, I'll tell you, on part B, this is where your calculator comes in pretty handy, okay? Because what they doing, they want the, what is the balance after T equals 1, 2, 5, and 10 years. So knowing what they're investing, knowing their interest rate, I can estimate what'll be in my balance after all these years. So they'll have after 1 year, after 2 years, after 5 years, and then finally after 10 years. Now, I ain't gonna lie. You can put a 1 in for the T right here, punch this whole thing in, see what you get, and we're rounding them 2 decimal places. Then you can come to this one, put a 2 in for the T, round it 2 decimal places. You can do this 4 different times. But y'all, we got a graph and calculator, so watch this. I'm going to share the calculator. I'm going to go to y equals. All right, let me clear that old stuff off. I'm actually going to put in that equation. 14,957. Then I got my second ln to get my E. Now the exponent was a 0.064. Now, instead of T on the calculator, we got to use the X, okay? Now, I don't even want to look at the graph. I'm going to go to the table by hitting second graph. Now, you see how, let me arrow down to 1. You see how when I arrow down to X1, it's giving me 15,946, but that's not giving me the decimals. So y'all watch this trick. If I highlight the Y value, look down here in the bar. It's got Y1 equals 15,945.5440083. I'm going to round that 2 decimal places. That'll be 15,945.54. So my first 4 don't round up because I got a 4 behind it. Now,
I have a
next one.
question.
Uh-huh.
When you say, like, okay, after you enter in the y equals, what did you hit to get this part? Because when I hit table, it brings up a graph. Well,
Yeah.
it tries to bring up a graph.
So since that table's blue above that graph button,
Uh-huh.
hit the blue button and then the graph.
Oh, second, then graph.
Uh-huh.
Okay.
So there was 1. So now I go down to 2, 16,999. But if I highlight the 16,999, the Y value, y'all look at it, it's giving me $16,999 and, well, 42 because the 2 is going to stay the same because it's got a 3 after it. So 16,000 $999.42. All right, my next X value was 5, so I'm going to arrow down to 5. And I'm going to arrow right onto that Y value. And y'all look at that, 20,597. Point. So y'all, what would y'all round to 0.699 into? Because I've got to go 2 decimal places. But we got a 0.699 sitting there. Oh, y'all let me get you on that. Well,
7.
oh, what was that?
70.
70. Good job. Yeah, a lot of people don't remember if you round that 9 into a 10, that 6 does become a 7. Good job. All right, what
I
was
have
our
another
last one?
question.
I hear you.
If my X table is showing decimals, how do I fix that?
Your X is showing decimals.
Yeah, it's
Okay,
not
so watch
showing.
what I do on my screen, okay? I'm going to
Okay.
hit second window. You should have that pulled up.
Yep.
Started at 0.
Okay.
Arrow down, and that means the change in table, put that on 1.
Okay.
Now hit second graph and go back to your table.
Okay. Thank
So
you.
you should just have nice whole numbers now.
Yep.
Yeah, what happens when we was doing that one problem where we were looking for zeros and stuff, and we had to change the graph to find that fraction one. All right, y'all, so 10 years, let's see, it should go up. So that looks like 28,365. Point 66. It's got a 4 after it, so I'm gonna keep that 66. So although when you're over here, all you see is the whole numbers of it. Like I said, if you click onto them Y values, you get the decimal form of it too, okay? All right, y'all, then let's see. This one had one more part on it, part C. So part C on this, the doubling time is blank years. All right, well, we know doubling time. Remember, capital T for doubling time equal to ln of 2 over my K, which was what? 0.064. All righty, so round that 1 decimal place. So let's see. Let me get that calculator back. So I'm gonna quit the Y equals. All right, so I had a ln of 2, close parentheses, divided by 0.064. And we're going to hit enter and round at 1 decimal place. So that's what, a 10.8 because I got a 3 after it. Okay, so that'd be 10.8. And you'll just put that in the blank. They already got the years after it, okay? All right, so then this section sort of mellows out pretty good for us. So y'all, let me show you what we got coming up. So now this section, the last 3 homework problems are doing exactly what I'm about to do on this next one, okay? So 4, 5, and 6 are all doing the same thing. So I'll probably do a couple of these, okay? All right, so this says the number of books in the small library increases according to the function and they actually give me the formula, y'all. It's B equals 3,700 E to the 0.02 T. So to give you the formula, what they want to know is how many books will the library have after 2 years? Now they're starting with 3,700 books. That's their initial books. So what we want to do is find how many they got after 2 years. So y'all, all you're doing on this, you're putting a 2 in for that T, and you're going to round this to the nearest book. No decimal places. But you do have to look at the first decimal place to determine whether you're going to round up or down it or leave it the same, okay? So y'all want to punch that in and tell me how many books my library will have. Now we'll say this one, they do give you a multiple choice answer, okay? Oh, you know what? Vita, you're so close, but what's after your decimal? 3851, perfect. Okay, so y'all remember, look after the decimal to see whether you keep that a 0 or whether you had to round it up to a 1. All right, y'all, so let me show everyone else how we punch that in. Good job. 3,700. E, remember I do second ln. My exponent is 0.02, so 0.02 times T, which was 2 years. And then, so what happened? That 9 turned that 0 into a 1 on that, okay? All right, good job. So my last question deals with what we call a decay. So this says the number of acres in a landfill is given by the function B equals 3,800 E to the negative 0.05 T. So y'all, since my growth rate is negative, this is actually a decay type problem, okay? So since growth rate is negative, this value decreases. Okay, so positive increase, negatives decrease. Now, what they want to know is how many acres will the landfill have after 9 years? So y'all, they're giving you what you're plugging in. They're telling you a 9 is your T. Plug that in and tell me how many acres will my landfill have, rounding to the nearest acre. And we know it's got to be less than the 3,800 they started with, okay? So y'all punch that in and that'll be a wrap.
Um, is it going to be 24 to 2?
You say 2423, and that'll
Yeah.
be in acres. Good job.
Okay.
So see, y'all, let me show you how that actually looks on the questions here. So Vinny would have got hers because there's a 3851. She wouldn't have seen 3850, so she'd have known, oh, I gotta round that up. And then you just said 2423, which would have been my D right here. So they're actually giving you multiple choices on these ones. So y'all, you'll be able to tell even if you didn't round it right, there's only one that's going to be right where your number is, okay?
Sounds good.
All right, y'all. So y'all got any questions on that? And guess what? That is your college algebra year. All we got left is a bunch of tests. Remember, Thursday night, I'm reviewing for test 4. And then next Tuesday night, we're reviewing for the final exam. So that one will have 25 questions. And the one we do Thursday also has 25 questions, okay? But y'all gonna love the final. It's all multiple choice. So it makes it nicer.
How many questions?
25. And
Did we have more last year? I saw we had more.
say again,
Did we have more of those last year?
more questions on it.
Yeah.
If you was in, say, foundations of algebra
I was.
or transitional algebra, I think their finals do have probably more questions. But
Yeah, I think we had like almost 46 questions last
yeah,
time.
and then some of them, but the college algebra has always been 25.
And you said it's all multiple choice?
They're multiple choice, yeah. Actually, if you want to look
Oh,
at it,
wait.
listen, if you want to look at the final, go do the review or look at that review. The review
Mhm.
member is just like my final. And I've got it open already, so you can sort of look
Okay.
at those and you can see how it's all multiple choice on that, okay?
Okay. That's awesome because that gives me way more confidence.
Oh yeah, because if you work one and you say you got an answer, oh, they got it on there and you can be like happy, right?
Right, because that's like the issue. Like it's like I think on my last test, I was close with the
Uh-huh.
answers, but I was like a little bit off. But I mean, how would I know if,
Exactly. So now you don't have to guess whether I got to put parentheses around them X values or do I got to put an X equals or, it's all there for you. Nancy, was this the page you needed?
Yes,
Okay.
I'm still copying.
Okay, that's cool. I just making sure I had the right one. And I'll tell y'all what, for the final, the final was one like the library book question I did right before this one. That's one of the questions on the final. You're just plugging in for the T, punch that in, and get one of them A, B, C, D answers on that. So yeah, the way that question I showed you the answers is how all the final is. And that's nice because that gives us more time next week on Tuesday to just worry about that final. So y'all, there is a support assessment quiz Nova's asking about. And I was going to explain that Tuesday. But what that is it's an assessment over only the support material. But this does not go against our grade. It's just 10 questions doing support type questions. Okay. So y'all, guess what? Depending on the outcome of the last two tests, y'all have made it through my college algebra class. So y'all are happy now, right?